So this is one doctoral course. It's part of the doctoral course program that is sponsored by the CY Sergi Paris Université, also by the CY Advanced Studies, and the LPPI is the laboratory that is hosting me in this Fellows in Residence program. I'm Professor Demetrio Filho, Fellow in Residence for the year 25-26, Professor at the University of Brasilia. So this course is on the website advancedstudies.cyu.fr. I asked to add the links to all these presentations. So at certain time, when you open the site, you see the course, you will have the links. We will have all 6 classes, all the slides directly in Canvas that you can access and you can review, remember all that has been discussed during this time. There's also the recordings of these classes that you can review if you want. So we are in our 4th class, which is about bibliography research and reference management. Then we'll have this break, vacation, and 1 week where we will have no heating in the building. And we restart March 11 and March 18 with the 2 last classes. In March 11, I will discuss about ethics in scientific research, publication. So, for example, what is the role of each author in a paper? What is the responsibility? What means being the first author, the last author, the correspondence author? All these details that sometimes for the students that are entering in this field, this is not really written anywhere, and you just learn as time goes by. I myself, I took quite some time to learn the importance of these items. So I will discuss about that. We will touch slightly in the point of AI use in this next class. And in the last class, it will be dedicated only to this scientific writing with AI, risks, biases, misuse, and etc. I also want to tell you about this AI Day that we are organizing. This will happen the 30th of March here in the auditorium. We will invite 2 very important researchers in this field, and we will have 2 classes. One which will discuss 2 talks. One that will discuss how artificial intelligence algorithms can help in your research. So the idea that we start to see somehow it looks like still a dream, but on the other hand, you see results coming up. We have the first antibiotic that has been designed with AI, although we don't know exactly what that means, being designed by AI, but we start to see this news. So the first talk will be discussing that. And there is already one project together with LPPI with this idea of designing new molecules, new polymers for electrochromic devices. So we'll discuss about that. And the second talk, we'll discuss about the use of AI. It's a professor that one of his researches is to follow how students are dealing with learning programming in the AI age. So imagine before 2023, we would have a class which, for example, the idea was to teach you how to do programming, and the exercises would be write program to do this, to do that, etc., etc. So this was the idea of the class. after 2023, does it make sense, a class like that, right? Because all the exercises, you just go to ChatGPT, copy and paste the list of exercises, and the programs are there. And there is no, or it's very difficult for a professor to say, you didn't do that, it was ChatGPT. Unless, of course, it calls you and say, write in the board the program to do this. And then most of the time, students will not do it. So this will be on March 30th. Please take notes in your agendas and join us in this too. When you are presenting your thesis, when you are in a conference, time is really important. You have sometimes 10 minutes, 15 minutes to present a lot of slides. And one thing that I marked here in red is every element you add to your page takes cognitive load to process. So start with a blank page. If you put a dot, your brain processes something, right? So take this word cognitive load. So the idea is add only the essential information. So your audience will have enough brain power to process the information you presented. Remember that in a presentation, sometimes you show an image with a figure, and shortly after you have to change it. So if the figure is not really simple, what will happen? That figure will be useless, right? Because there is no enough time to process all that information in the time you have to present. So these tips, they are very important for presentations, number one, and also for proposals. Why? Because proposals, although they reach the referee, let's say, in paper, like an article, sometimes you are pressed to finish up reading and giving the evaluation of that proposal, because sometimes you have many proposals to evaluate. So in practice, the proposal is like a mix between an article and a presentation, that you try to add the details, giving the reader full control, but also you have to be a little smart to present things in a way that's more easy to read, easy to flow, right? So these tips are important, especially for these two cases. So the first graph that is in the book that I mentioned, the storytelling with data, is the simple text. So I will show some suggestions about graphs that you already know, and some graphs that you probably never seen. So the idea is, keep in mind that if you ever have to present a data in a proposal, in a presentation, sometimes for articles, some of the graphs, they are not very appropriate because people are not expecting a graph like that. But in proposals and presentations, remember that this may be a suggestion. So let's start with this graph. So we have here a figure that has 2 years, 17 and 2012, and 2 bars. One say 41% of the children with a married stay-home mother and a working husband. So in 70s, it was 41%, the mothers that stay home. And nowadays, in 2012, it's only 20%. So this is a graph, simple, no problem. But look at her suggestion. You just take a big number, so your figure will be a big number, 20%. And then 20% of the children had traditional stay-at-home mom in 2012 compared to 41% in the 70s. So this is way easier to process, and you keep in mind the number that really matters, which is 20%, right? So the idea is to call attention to you to this big number, 20%. So it's easier to mark in your hard drive this number. So this is they call simple text. The other one are the tables. So tables, especially in a live presentation, is often a bad idea. Why? Because when your audience reads, you lose their ears, because they are using their brain to process, to read the table. You take a table like that, to really understand this table, you have to read everything, right? You have to remember that this is category A, 15%, 40, 35. So to compare things is quite complicated, right? You take a lot of brain power to process all of that. And for example, if my purpose is, what are the largest numbers in this table? So you have first to read everything, and then you have to realize that this is a big number, this is a big number, and this is a big number. But you have to scan everything. So what is her suggestion? Is what she calls, and it's called known heat map. What's the heat map? So you give here a scale. This scale is only 2, gray and blue, and you highlight the cells with some scales of transparency. What are the big numbers, the smaller numbers, and the very small numbers? So when you do that, look at what you do. You reduce the mental process because you use color, meaning the heat map, to provide visual cues, visual suggestions, right? So this heat map, you can easily, this one is a strategy that you can add to a paper in a very large table, for example, right? If you want to call attention to certain numbers, you can use a heat map scale, and this heat map scale, you can have, for example, the visual spectrum. You can go all the way from red to blue, showing that this is the gradient of numbers. So this is a very powerful tip, useful in papers, presentations, proposals. Now, here's also where the design ideas of someone like the author of this book shines, because it gives us suggestions on how to make our plots way more easy to read. So important to remember that tables interact with your verbal system, and graphs, they interact with your visual system, which is faster at processing information. So in presentation, especially, that you want to improve the speed of processing, you should prefer graphs. But over there, in presentations, as you have very low time to process this information, it's very important that, first of all, you clean up your graph. So every point you put in the screen takes cognitive load. So if you put a line here, another line here, if you put a mesh of lines, everything takes cognitive load. So you have to get rid of cognitive load. Present your graph as clean as possible. What's the idea behind this graph? This idea shows that cost per mile versus miles driven per month. So the idea is, when you ride low mileage, sometimes the cost is high, and there is a region here where is what the Americans call the sweet spot. So it's the amount of miles that really makes sense drive per month. So the cost is below the average. So here's a graph that I think everybody could put in his presentation and have no problem to understand. But look at the design suggestions. Look at how powerful simple changes can make big difference. First design suggestion, put a line separating these two regions, the region above the average and below the average. First suggestion. Second suggestion, change the color of this font. So now it makes really obvious what is the the range of miles that the cost is above the average. One of my suggestions that I could give, sometimes in our domain, we want to be very precise, we want to say, so I would even add a little inset here saying, if you want to have a number, this number is between 1,800 miles and 32,000 miles, whereas the cost of miles driven per cost of driven miles per month is below the average. So you see, very simple changes that anyone that's able to do a graph like this can make a graph like that. It's much simpler to understand, right? And call attention, just changing the colors of few points. Sometimes, in practice, it takes some extra steps to do that, right? Because if you were going to plot this graph, you have just 2 columns. Here you have to separate the points. You have 4 columns now, but it's worth the effort. Okay? Another one. This one I thought about you when you were discussing about error bars and etc. So, and actually last week I refused the paper because the authors they didn't show the error bars. They had measurements and they said, look, A is better than B by 10%, but only 1.1. So I said, is this 10% real? Or is a minimum of a range, is a maximum, is the average? So when we are dealing with experimental values, this is a plot sometimes that we need to have. So for each, for example, number, you have to take the minimum, the value, the average, or the minimum, the standard deviation, right? So in experimental measurements, values, they always have an average, standard deviation. And this is one example of a very nice graph that you can do. So this is just a passport control wait time, some data that the author found in the literature. But you show very nicely the average curve, which shows you more or less the trend. And here the minimum and the maximum value in a shaded gray. So you have the 2 informations, but the most important, which is the average, you highlight in black, right? Many situations, people would use only the average number to show. And at the end, if you do that, you always ask, but how this number is representative in a group of several numbers? Is really an average between maximum and minimum? Is just 1 point that you don't have any information about the average? Things like that. Okay. Another graph that sometimes is quite useful when showing data is what they call the slope graph. So what is the slope graph? It's just the idea of showing how things changed, let's say from 1 year to another. So you have just a slope, right, between these 2 points. After reading this graph, what strikes you? Is there any difference that you could see? This one is different than all the others. Just one, right? Just one decrease. And if there were more, you could also do this highlight. So see what is her suggestion. Simple there, right? So most likely, when you present this graph, you want to show that. You want to show that among all the situations, career development was the only one that decreased in this field. So just give you a little touch of color to highlight, and this will just pop up from the graph, right? So the idea is really reduce the cognitive load as you present. This one is quite interesting. I like this one very much. This is looks like a picture that was taken from the TV screen, right? And with a bar graph about the in the election time of Bush, president of the United States. So what she comments, bar charts are well known and easy to read. Everyone look at a bar chart is easy to read. But when you look at a bar chart, what you look at most of the time? Which part of the graph you look? The top of the bars, right? So when you do that, when you look at these 2 points, when you see a graph like that, what this transmits to you?
Main difference between those and scale.
Exactly. If you only look at that, you just to the edges of the bars, you say, wow, there's a big difference. If this changes like that, or either you go to a very nice position or a very bad position, right? But there is a catch here. And sometimes the idea is the who made this graph had this bad intention. What was the bad intention? Showing the baseline, not showing the baseline, changing the baseline. Why this was a bad intention? Because when you redo this graph, putting at zero the baseline as it should, you see that the difference between the two columns are not as big, right? As a matter of fact, when you do the right way, the difference is 13%. So it's only that little space here, 13% in height, no? And if you do a zero baseline, the difference, and the way it was presented, the difference between these two is 460%. So this bar is almost 5 times higher than the other one. Whereas when you do in a proper way, it's only 0.1 higher than the other, right? So this is one idea for you to, if you face bar graphs and you see something strange, look at the baseline. And of course, avoid not using the zero baseline in your graphs. Here's a graph that I decided to show because I myself never seen it before. And when I saw it, I went to Origin Plot, which is the software I use to make my graphs, and it was there. Oh, look, I never used it. What is the idea of this so-called waterfall charts? Is when you have, most of the time, a beginning and an end. And you want to show what was the evolution, starting from the beginning and then to the end. Especially if you have, for example, additions and reductions. So you can say, for example, the idea here is number of employers transferred in certain company. So you start in the beginning with 100, you had hires, 30 plus, then you had transfers in the company, 8 plus, then you had the deductions, 12 minus exits, people that left the company, 12, 10 minus, so at the end, you end up with 116. So this is one type of graph that you may show very wisely these deductions and reductions, right? Compared, for example, to just a bar chart that you could see you have only the bars and not especially focus on the difference, right? On what happened plus or minus. Another one, which is also quite interesting, and when I was giving this class to a group of students, they said they use quite often in displays of markets fraction graphs that show quantities that sum 1 or 100%. So here you can have, for example, the example of a survey, and you have strongly disagree, disagree, neutral, agree, and strongly agree with this heat map. And you saw the sizes of the bars summing up to 100%. So you can easily show, for example, agree and strongly agree. These are the fractions that agree, strongly agree. Another one that's also very common is this one, right? When I was in the States looking for a position, this was a number that I had in mind. For example, what is the statistics of sending letters for positions that are open versus the number of people that are interviewed? So they are first selected for a campus interview, and those that are really hired. So in the process of professors was way more difficult. So it was like 100 letters, campus interview 2 or 3, and at the end, just one hire. So the idea was start with at least 100 letters if you want to have a chance to be hired, right? So you see this graph sums up to 100, and a student told me that this is very used in the stock market, so you can see market share and etc. It's very easy to see market share with that. Another one is the pie charts. It's interesting from the word used that in English is pie, in Portuguese is pizza, and in French is camembert. Cheese chart.
No, like camembert is a type of cheese.
But my French teacher said that was camembert chart. She said, is that? So in English, pie, Portuguese, pizza, in French, cheese. So the pie chart, there is a catch in the pie chart that is our human eye is not really effective in ascribing proportions. In two-dimensional space, in three dimensions, even worse. So if you look at this chart, which one you would say is the biggest slice? The colors here are not very strong, but let's say supplier A, supplier B, C and D. Which one you would say that's the line? B, this one, right? But this is the three-dimensional effect. As a matter of fact, A is the largest one. So one suggestion, if you really want to use the pie chart, one of the design suggestion is put the numbers on the top. You can see that it takes CPU brain power to relate the color to each supply, etc. So if you want to make it really easy to the reader or to the viewer of your presentation, the suggestion the designer gives is this one. Now you did all the processing, you see? When you look at this, the audience, has to process that 34 is bigger than 31, then it comes 26, then 9. And then you integrate with what is supply A, B, C, and you put them into order. When you do a graph like that, you, the author, already processed all the CPU. You already put in order, you put the sizes, so the order is already given. You save your audience CPU time. So this makes a big difference when you have a 10-minute, 15-minute presentation and you have to move your slides. So at a certain point, if you start with that, figures like that, at a certain point, your audience will quit. This is what happens. Because what is the point? The person tries to follow. When he or she tries, getting to your point, you change the slide. And then again, you change the slide. So at the end, say, okay. And I have been in a presentation like that. It was in the Academy of Police, so most of the audience has nothing to do with the presentation. The guy was presenting statistics, so it was a talk on statistics. And I said, well, as a physicist, I probably should manage a little bit, try to understand what he's talking. And at the end, after a few slides, I realized he was just moving faster than I could process. And I quit. So if I quit, imagine all the others that had no idea of statistics. So try to do this process for your audience. Make it them easy to see obviously what you want to tell. Another graph that we often use in papers, and in papers, I tell you, it's much easier to process because we have time. But when you are presenting or writing a proposal, we don't have this time, so you have to be cautious. And I totally agree with the designer that this graph is inappropriate. It's what we call a two-scale graph. So sometimes we want to show two things that are correlated in the same graph. Very good idea. But how we do that? We put two scales. So one set of points will be related to one scale, another set to another scale. In the paper, you have time to process that if this is revenue, the bars are revenue, and the blue is size of sales force. Here I have employees, so this scale should be related to that. And revenue is related to that, so this is the scale of the bars. But this is in the paper. I have time. If you show that just like this, the audience has to process. So what is the first suggestion the author gives? First, disappear with the second axis and the first axis and only put labels to everyone. So now it's clear. Revenue is here, number of employees is here, these are the numbers, and those are the trends. Simple. You did a lot of processing for the people, for your audience, right? Alternatively, which is the one I like most, even for the papers, pull these two graphs apart. Put one in the top of the other with their own scale at the right position. So we train our brain that the y-axis is always on the left. So you just look, traditional plot, two graphs. Now, if you put one in the top of the other, then you will show that the two trends are following, right? So as you increase the number of people, the sales increase, but it's very easy to read. Yes.
If we put like, for example, same color for the X,
same color for the L.
Different color on the different sides to it.
It's very helpful. I have done that once already. Yes. So if you put, let's say, you color this scale in red, put the graphs in red. You color this scale in blue, put the graph in blue. Much easier to look at the two and to separate. So you give one CPU process, one CPU cycle to your audience, right? But in the case of presentations, the idea of the cognitive load is very important. So the more you remove from your graph, meaning remove the axis and then separate them, the easiest is for the audience to process. This is one example that I will end this part of the talk with the idea of cognitive load, right? Just to really concentrate this definition, and so you can leave this talk with this in mind. So every element you add in the page takes this cognitive load. So you identify, your motivation is to identify what is not adding to your graph, what you can remove without losing meaning, and just present only what you want, what's the focus of your graph. So here you see a typical graph that you could use in a paper. And here is a graph that you should use in a presentation or in a, for example, proposal. What you want to show? You want to show when these two curves, they separate, which was about this period of time. So you just leave these two curves, remove everything else, color them in red and blue, and that's it. Now this is clear. Okay? So the idea is reduce cognitive load. Okay. Now we move to the second part, which is the idea of bibliography research. So let's first define what is bibliography research. So what is not? It's not a collection of PDFs. Right? Sometimes you just want to collect a bunch of PDFs to have your library, and the more PDFs you have, the best your search was. Not at all. What it really is? The idea is that you map the intellectual landscape of your field. This is a very powerful definition that I really like. So your research is within a field, and you do a bibliographic research to search around this field and map what is the landscape, where you are located in that field of research that you are getting in. So when you do that, when you do it properly, you identify open problems. Remember when you're talking about when we discussed about the introduction, you say, first paragraph, what we know. Second paragraph, what we don't know. Those are the open problems. So it's not only yours, there are other problems in that landscape that you should be able to point all of them. And then in the introduction, say, okay, this is what's not known and what we are going to do. But you should be aware of the open problems, right? Those open problems, that there are also research gaps that you may address one or another, and in the future, other gaps. But really, the most important of mapping this landscape is this point: avoid reinventing the wheel. What that means? Doing what was already done. And sometimes we fall into this trap when, for example, it's a very recent paper, there was not much that you could do, right? Someone somewhere else is doing a research that's very close to yours, and by chance, they published before you, and there was not much you could do. But when it's something that was done way previously, then it just shows a bad bibliographic research, right? You didn't do it properly. So at the end, the good bibliographic research, the goal is understand what is known that you will add to your introduction, what is not known that you also will add to your introduction, and what is on debate, what is hot that you can also add to your introduction in the importance, right? So what is on debate in the community, what people are searching. So defining the bibliographic research, then I want to discuss a little bit of the evolution, how it was in the past and what is now. It's important to show that for me because, I was in this, I saw this changing, and I clearly see what are the pros and cons of the past and the pros and cons of the now. In the past, how it was. Before, we had printed indexes was a mainly manual library research. So first of all, the time scales were different because to print an index, the index was like for 6 months. So you published papers 6 months, and then at the end of these 6 months, it comes up a book. In the past, no, it came up a book indexing 6 months of research. So the moment you put your hand in that book, you could have a paper that was published 6 months ago. No? And sometimes you put the hand in a book like that every year because, like for example, in Brazil was the time when my advisor would travel abroad where they had these big indexes, and he could put his hands in such a book. After the internet, databases are easily accessible. Anyone with an internet connection can access Google. Others, you have to access through your university subscription. You have immediate access to the citations. Most of the citations, let's say, because if you are, for example, not in your university, you only have access to the title and abstract, but you have access to the citation, not to the paper, right? What is the difficult part in the information age, in the internet age? The information overload. So if in the past you had a small pile of papers that you knew by heart, nowadays you have access to hundreds, sometimes thousands of PDFs that are related to your research that you need to process them, right? So it's the information overload. So the speed increased, speed of search, of getting your hand into the information. The amount of papers increased drastically. So now it's critical to filter the essential. So you now have to invest time in filtering what is essential to your research. Because now you get much more than what you need. So this is the idea. Just to show you, I picked here some examples. So this was kind of the indexes that I just discussed. So you have the period, for example, January to June 45, July to December 45, and etc. So when you open a book like that, you have keywords. Those are the keywords in the paper. And here's the citation. So your bibliographic research would start in an index. Then you take note of your citation. These books, you had just to write down the citation. Then you go in the library to search for the journal, to search for the paper, make photocopies, etc. So this was the way we do. Nowadays, you have just a browser, you type your keywords, boom, comes a list of hundreds and hundreds of papers. And now what you have to do, filtering. And that's what we are going to talk in the next hour, how to filter this amount of papers that you have access to. So there are 3 types of searches that I want to tell you about. First one is an exploratory search. So here, the idea is what exists in this area. So for example, LPPI works in the field of polymers for certain applications. So you have a big area. So it's important for you to have a good idea of what's going on in this area of research. The development of novel polymers for what? For LEDs, for protection, for certain things, right? Many things. Because there are some development of polymers that they are in the past, they are not very interesting, but there are new applications. For example, I just had the opportunity to be in one of the thesis defense, and I loved that presentation about using polymers to protect arts, right? to protect paintings and objects and etc. So this is very interesting. So it's being developed right now, like new polymers that will do a good job just spraying some plastic piece and protecting it for a long time. So in this exploratory search, you have to use broad keywords. Development, polymers, year 2025, broad keywords. So this is an exploratory search. Many papers will come from that. Where you are going to use this? In the first paragraph of your introduction, when you present your area. Second, focus search. Now you enter in your research. Now you have to know your keywords, your materials, your methods, your model, and you do a focus search using specific keywords that are of interest to you. So this is the second type of search. We start with exploratory. Second one, focused on your problem, let's say. The third one is one that, as I mentioned to you, is available. I understand, I believe that you know, but people do not make much use of it. And actually, I was in a WhatsApp group with professors and friends, and someone mentioned, oh, certain professors cited our work, and they said, but how you know? I was surprised, that people were not following that. How you do, and this search is related to backward search and forward search. If you have a topic, how you believe you can do a backward search and a forward search? Backward and forward in time. How you imagine this is done? You take a paper, a review paper, very important, as we mentioned. How you do a backward search with respect to that paper, and how do you do a forward search? Then,
like the graph that was stated in this article, and for the forward search, you try to find the articles that cite the one you want to.
Perfect. Exactly that. In practice, how you do? Simple, click and click to do that. So just to summarize, backward search are the references, forward search is who cited this. Now in practice, how you put that idea in practice? Backward search. Easy way. How you do it? Because sometimes, for example, if you take a Nature communication paper, if you print the paper, it would be something like that. Cornell, Rev, page tab, that's it. No title, no authors, the minimal information to reach that citation. So how quickly you do this backward search? One suggestion is open the page, the web page of the paper. Most of the magazines, they have the HTML version of the paper. And the references are there, just to click. Easy, right? Now, the second one, the forward search. How we do it? Take the review paper, as you mentioned, find who cited this, and look through the paper who cited it.
So the website have a category where you can add an article.
Two ways. In the article page, you have sometimes who cited this. This most of the time when you're talking about Web of Science, when we're talking about citations in articles, most of the time those are other articles. You restrict to other articles. because all the links are made using DOI. If you go in Google Scholar, you have the same thing, sites, click there. But when you go in Google Scholar, it's everything. So there is a saying in Brazil that every scientist is prettier in Google Scholar, meaning the number of citations of a scientist is always larger in Google Scholar. Why? Because in Google Scholar, if a thesis cited you, you have a citation. A website cited you, you have a citation, right? But in Web of Science, it's only papers. So you can go in Google Scholar, click citations, and open up a list. Who cited that book? So that is the forward search. Now we will discuss why you want to know these two, or at least the three types of search, right? So why we need to know all of that? Because to map your research field, remember your field of research that you are moving, one of the things you have to do, you have to know is to find most cited papers, highly cited papers. This you have to know by heart. Oh, the paper of that guy, etc. Once you have these highly cited papers, that they are highly cited for a reason, right? You can start to identify what are the main names in your field, main authors. Another point, recurring journals and key methods used in this search. So those are 3 points that you have to know. Main authors, the journals, good journals, right? Because people who have highly cited paper, look, everything I'm telling here looks much like my French classes. For all rule in French, there is an exception. So of course there are always exceptions, right? But I'm talking broadly. Highly cited papers are related to main authors in your field, are related to high impact journals and important methods, right? Okay, so when you find that, you are mapping up your research field, and then you can build what we call the concept map, which is problem, methods, limitations, and gaps. So you can map all these key points in your research field. What are the problems moving around? What are the methods they use to solve this problem? Techniques, kind of experiments. What do you have access at LPPE? What you have not? Who has access to certain type of experiment, right? So for example, I'm doing a research now with Tantuan, and we need a measurement that he has at LPPE. Great. But if he had not, for example, the spectra time result, sometimes there are many information that you can extract from a spectra, but not any spectra, not just a static spectra. So what you have at PPE is you put a sample, boom, you take the absorption spectra, you take the emission spectra, that's it. But there is one that you make the absorption spectra and you take the fluorescence spectra as a function of time. So you see things changing as a function of time. It's not possible, as far as I know, to do it at PPE. But I have a friend in Denmark that has this setup. So if we need it, I could say, come on, let's talk to my friend in Denmark that he can make this experiment. So it's important that you know the methods, who has these methods available, what are the limitations, and what are the gaps in your area. Just one thing to keep in your mind, avoid shallow literature review. What is that? A literature review that at the end, you have a very limited range in your field. So it's a very close field, close sometimes to your problem, right? This is not interesting because sometimes if you have a very closed mind, it's just like having a closed mind, having a close vocabulary, right? It's difficult to make nice things with a very close, limited research field. Okay, so time of a little break. Just drink water and see if there are any questions in the audience. I will share with you a quick tip. Also, I wanted to make a class only dedicated to presentation. So I can agree with you that if you like this question, these presentations, and you ask Karim to sponsor another course like that, I will add one class only for presentations. But there is one that is like number one tip. Present in the given a lot of time. This is really fundamental, right? So if you have 15 minutes of presentations for your presentation and at 15:00. And I have seen lots of situations, very embarrassing situations, in the case that people didn't follow this strict rule. Especially in conferences, this means really a total respect, especially for the others, right? Because at the end, you have a slot. Let's say lunchtime is here, have few people presenting. You take the time, more than your time. So at the end, what you are saying, my talk is important than everyone else. So I will take more time the other day because there is a time to end. Right? And it also helps you to show that you definitely prepared, you definitely practice for that presentation. And so, for example, nowadays we have many tricks. In the past, for example, I had a program. Nowadays, it's difficult to find it, and it only is useful to present PDF. So if you had a PDF, the program will add a little clock right here in the corner that you could reset. It was so small that only you could see. And it will also add a bar, a progress bar. So you could be all the time checking the time and where you are. Because sometimes, if you have especially a long presentation, it's difficult to keep the pace, to adjust the end at the end of your talk. But if you are watching the time and see how many slides you have left, if you have this information, you can manage to finish right on time. And this should be the goal, right? So let's keep moving. Reference management. Yes, please. Very good presentation. Very good question. I will answer that. The short answer is yes. The not so short is do it with careful. Be very careful. Why? Because one of the things that it's clear in the community is that AI creates references that do not exist. Right? So there was a very well-known neuroscientist, professor Brazilian, that he's working in the States, that he said he was reading a paper, and then he saw a reference, and he went to see the reference, and it was his name with another very important guy that he knew. And he called the guy. We published together. I know you very well. We are friends for a long time. I don't remember this paper that we published together. This paper doesn't exist. This reference was made up, was created. So at the end, that's the only word of caution. Another point that we will discuss in the last talk is AI models, these large language models, that are starting to move in the sense of interpret what is going on, right? Because at the end of the day, what you want? You want an AI tool that you give some, let's say, not only keywords, you give more than that. I want papers that talk about this thing and that thing, etc. etc. So the AI, you expect AI not only to cross the keywords, because keywords is easy. You Google Scholar does keywords, right? But you want the AI to read the paper, interpret the paper, and say, oh, this paper is what you want. Okay? So AI models are still moving in the direction of presenting good interpretations for the paper. So that's why you should not trust 100% when an AI tool says, this paper is good for your purpose. Because the interpretation that AI did, that this paper is good, maybe it's not really good. Okay? So I want to give you another example that I like very much. So there was a professor in Brazil, he was looking for catalysts, how to build catalysts for some process, for example, water speed. This is a new trend in the literature that is to build your own AI environment. So, for example, the AI of Facebook called Llama, it's available. You can install in your PC, but you have to train it. And how you train it? So he collected in the internet, I think it was something like 60,000 papers in the subject of catalysis or something. He put all these papers in the AI and started to make questions. And at the end, he found very good suggestions. But looking at the results, he realized that the AI model was not being able to separate what is good than what is bad. Like you wrote a paper, you had results, the results were not good. So that the AI model was counting that as a good possibility as well, because it was not interpreting that that was not good. So in this next step, he was trying to implement in the model tricks, labels, saying, when you find this, interpret as not good. So do not give a good weight for this material, because this material is not good. So we're still moving this direction. But yes, AI can be very useful, but everything that AI gives back to you, double check, double check. And I will even show you, for example, that the software manager kit that we are going to show you, it already has, for example, summarizer. So you take the paper and you click summarize this page. It will summarize for you. LLMs are very good to summarize, to create summaries. So maybe in this way, if you ask just a LLM to summarize a paper, it will be a little more interesting than just asking for reference, good reference. Right? Any other question?
Like, can use like the AI to summarize and to find out some key of the papers. Like every day I can insert 5 papers in the AI and say that summarize and give me some important parameters for this. So like, can I do like that?
People are doing that, and there are, for example, I heard about a tool. I don't know if now it's already available everywhere, but when I heard about this tool from Google, it was available only in the States. So you had to do a VPN to the States, and it was Google table tabletop or something like that, that you do that. You put a group of papers and you ask, please give me a summary of these papers, what they're talking about, what are the main points, etc. So people are doing that. And actually, this everything that involves AI is changing very fast. So something that I tell you now, maybe tomorrow is not true anymore. But even the editors, even the journals, they are using AI to pre-process the papers. So, for example, one of the things that they realize is good, the paper does, the AI model does very well, is to find if the paper is with the ideas of the journal, right? So each journal has some kind of ideas to publish, right? For example, journal like Nature, they are more open, but if you take a journal of material science, what is of interest to the journal is new materials in energy, etc., right? So nowadays, when you submit a paper, one thing that's done immediately is the plagiarism check. So you can check if your paper has plagiarism. But now there's another check that some journals are using with AI is if it has adherence to that journal. So remember, probably I have many times seen this answer. I can submit a paper and the journal say, "Oh no, your paper is not really on the area of our interest, etc." Or it's too specific. You want things more general. So this is what we call adherence to the journal. So you write a paper and the paper has to have adherence to the views of the journal, right? And they are trusting AI, some editors, to find this adherence, to see if the paper has. The AI has to do what? Read the paper and give an opinion, right? So it's changing, and maybe in the near future, this will be like standard in the bibliographic research. Give papers to AI, ask a summary, ask, is this paper good for me? Like you tell the AI what is good for you, and you put a bunch of papers, maybe even like 60,000 papers, and say, select what is the best for me. Right? Actually, this professor told me that the editors now, they are kind of arranging in thinking about the business model on how to sell this package of papers. Because he had to do manually, one by one, with all his group. But imagine if you could go to Elsevier, for example, which is a big journal, and say, look, I'm trying to search new polymers for blah, blah, blah. Can you give me 60,000 papers block? Can you sell me? No? Can you sell me a 60,000 paper block so I can build my own scientific ChatGPT only with that, only with this paper. And they will give you a zip file with 60,000 papers, put in your model, and you have a ChatGPT only for that. So this sounds to be a way that people will sell papers in the future. So reference management. I like very much this definition that says the reference management is a structured process of collecting, organizing, and citing scholarly sources to ensure clarity, credibility, and reproducibility in research. So the reference management, it is all these three steps: collecting, organizing, and citing. So it starts from the collection and ends when you are writing a paper and add the citation. Right? So this is all about reference management. Another citation that I like definition is reference management is the intellectual and technical infrastructure that connects prior knowledge to the new scientific contributions. So the new scientific contribution will be your paper. You want to connect what was done before, prior knowledge, to your paper, to your new paper, right? So this you need a good reference management. Why reference managers, they are not optional. Without one is citation chaos. So it's difficult to control what you have cited, what is missing. There are version conflicts. So for example, as you move in your paper, sometimes you delete a reference, but you delete it only in one place. You forget to delete in the other. Wrong formatting. So this is the most painful thing that I remember doing before a reference manager. Every journal has a format of references that it asks the authors to do. And if you submit a paper, sometimes I took hours formatting the references to that journal. You submit the paper, you realize the paper will not be published in that journal, you have to change it. You have to go every reference and change it again. And sometimes that information is missing, so you have to go all the way back in the papers, take the reference. So it's just not possible. And lost references simply because you are not organized. With one, everything is reproducible, you gain in speed, you have the style flexibility, because if you have your paper, Word, Mendeley, for example, which is the software we will discuss, is connected to Word. You set up reference style for Journal of Chemical Physics. All your references are there. Oh, no, Journal of Chemical Physics is not good. We will try another journal. You just change it there, boom, automatically all the references are rebuilt for the other journal, right? So style flexibility and research memory, as we will see, that you can do with these managers. Main reference manager. So you have these 6 suggestions that I gave you, only to be complete. Zotero seems to be the most used in the academia, but I used particularly Mendeley. EndNote was the first one I used, was the first one I heard that for Windows to work with Word, but it's paid. It was paid. Now, maybe there is a free version, but it was a paid version. RefWorks is also paid. JabRef is for processing text called LaTeX. It's very useful, used in mathematics and other fields, not much used in chemistry, this LaTeX processing, and RefBase. Here in this presentation, we will concentrate in Mendeley, which is the one I suggest. So the Mendeley reference management, just a quick history background, it was founded in 2008, so not so long ago. It's designed to combine reference management, PDF organization, and research collaboration. These are 3 very important things because, for example, the reference manager, the old ones, the EndNote, for example, you only have your references there. In Mendeley, you can add the PDF. So it's actually 2 things. It manages the references and manages your PDFs. And the research collaboration is, for example, you can have a professor, your professor, if he's very well organized, he has these papers all categorized in a folder, he can share with you his group of papers. So it's a very good starting point for your research. So it quickly gained popularity in these STEAM fields, which is science, technology, engineering, and mathematics, and was acquired at the end by Elsevier in 2013. Now it expands his integration to other scientific databases. So you can do search of papers within Mendeley. Why it became popular? So it has free access with some storage limits if you are not paying account. So it's like a Gmail, right? If you do not pay, you have some gigabytes. For me, it's enough because papers now are very small in size, so you can store a large number of PDFs. It has a very strong and good integration with Word, which is at the end the most popular editor. It's easy to import PDF and metadata extraction. So one of the ways to add the reference, which is the one I suggest you to do, especially if it's an important paper for you, is just to drag the PDF and drop in memory. So it will be already integrated to memory, and it will extract the bibliographic information. Very nice. It has cloud synchronization, so this is also very nice because everything you have in your computer is synced into cloud. You have access to the internet. So if you are working in your laboratory, you go home, oh, what was that paper? So you can go website manually, open the paper, read, take notes, etc. And if you are using another computer, you still have access. If something happens to your computer, you have all the PDF backed up in the cloud, which is very good. And the collaboration features that I mentioned, your collaborators can share with you papers or block of papers in one time. So some skills. So Mendeley can access the metadata of each article. So it can grab the name of the authors, the journal, the volume, page. And this is important that you check that if it grabbed correctly. Because, for example, sometimes there are papers that they have not page numbers, like sequential page numbers, but a six-figure number that indicates like the volume, and the pages is all the article, and the page is 1 to 4. So in physics papers, they are more like that. So you have a number that you could reach the paper with that, but the page numbers are actually 1 to 4 or 1 to 6. Right? So at the end, it's important that you realize if Mendeley extract properly the pages. Why? Because there are some formats, for example, literature reference format in journals, that they ask initial page and final page. So if you put the article in Mendeley and you find that it didn't catch the final page, sometimes you have to do it manually, right? Or incomplete or incorrect information. So another thing that's quite nice in Mendeley, and now I will cover this field, which is types of references. Of course, the primary references for our papers is other papers, right? These are our primary source of information. But there are many other things that you could add as a reference. I put a very short list, but in Mendeley you have a long list. Because sometimes you don't know how, for example, you will present a film as a reference. What kind of information you put? So in Mendeley, when you add a reference and you say field, it shows lots of fields which you will be adding to categorize a reference. Okay? So, for example, not very common, but interviews, technical reports, web page. So how I cite a web page, right? So, for example, in web page, it's important that you cite the date you visited that page. Because sometimes in the future, if someone goes in the page and there is no page, well, it disappeared. But at that date, when I clicked, it was there. Insert and manage citations in Word. So you can insert in-text citations, automatically generate a reference list, update numbering dynamically, and avoid manual citation editing. So imagine in the past when we didn't have such software, and every reference that we add, we had to change every place for all the other references. It's a nightmare. No? Nowadays, you add another reference, you take one reference, everything is automatically updated. So that's why you really need a software like that. Citations style you can change easily. So there are many journal formats. Sometimes different journals use the same format, but slightly different way. So for example, in Nature journal, you cite all the authors. In Nature Communication, it's just the first author. So all these little changes, Mendeley will do it for you automatically. And ensure formatting consistent. So all the references are cited the same way. And the idea of importing and organizing PDFs. So you can import directly from databases, attach to Mendeley, so you can make your own group of PDFs, use the automatic metadata extraction, and what we discussed in other classes, organize your papers using tags and folders, right? So you can group papers, like papers for introduction, papers for results, papers for discussion, things like that. For example, for each important paper, you can use tags and just suggestions here, high impact, review paper, right? And this is one that I really strongly suggest you to do for your important papers. Write a 3 to 5 note in the space that Mendeley gives you. And for example, you can highlight the main result and why this paper matters to your work. So this will be very easy for you, maybe months from the time you read that paper, to remember why I read this paper and why I read it as important. Right? Just a quick note on the Mendeley note side. Important correctly. So how you can import to Mendeley a citation? So one way, which I do not recommend, but is possible, is using Ref Manager, Google Scholar, and the RefMan archive. So when you open Google Scholar, you search a paper, you click on the paper, there is a quote that says cite. You click there, it opens a window with the citation in 4 or 5 different types that you can copy and paste. But on the bottom, there are some links. One is BibTeX, another one is RefMan. If you click there, it downloads a file. That file can be, for example, this RefMan type that Mendeley understands. And then you import in Mendeley, the reference is there. I do not suggest that way because there are more efficient ways, as I will show you. So, for example, one way that is more convenient and easy is using the DOI, the Digital Object Identifier. So right on the top, when you click Add Reference, there is a window saying DOI and a little loop. And then you just put the name there, click Search, it will pull from the database what is the references for the thing. That is the preferred versus the other one. But the one that I really think is the most efficient is really dragging the PDF in Mendeley, and I will show you why. So here is more or less the screen of Mendeley. On the top, you see the add reference button. So here is just showing you to add with DOI. So you click add references. When you click add references, you can add manually or import the file, as I mentioned. But when you say add manually, one way is to using the DOI. So I click here the DOI, click the search button. It will populate the information. So here's the reference was added, and here is everything it collected. Number of the authors, year, journal type, pages, etc. So you should always check, for example, if it has the initial and final page. Because some journals, they need these two information. Now, here is the tag that I mentioned to you. So you can add tags to the journal, say tag theory, tag most cited, tag, etc. And after you can search using these tags to make more efficient. When you drag the paper into Mendeley, the PDF, if you download the paper and you drag, then the difference is it will add a file here. So the file will be part of Mendeley, right? And one thing that's interesting is, for example, the abstract is extracted as a metadata. So in the previous, not. Here, when you add, you have this abstract as an extra information, okay? Now, once the paper is inside Mendeley, then there are some things that are very nice. First, you can open the paper and you can do that reading I suggested you, highlighting part of the papers with different colors. That could be your strategy to highlight what is result, what is good for introduction, what is good for discussion, etc. So you can use the highlight tool, you can change the color, green to red, and you can highlight the papers, and Mendeley will keep those highlights. So it will be just like you had the paper and you highlight and you keep in your pile, so it will keep the highlighting as well. Okay. Another thing that, so you have here, it's quite small, but I read for you. You have info, annotations, notebook, reading assistant. So this is the info, the highlighting is on the paper, but then in annotations, you have that field where you can add your notes. So you can add 3 to 5 lines, just explain why when you read that paper, you found it important for your research. 3 to 5 lines. This will help you quite a bit in the future. There is another tool that Mendeley has in this reading assistant. You see reading assistant Gen AI. So it has a built-in AI that summarizes the PDF. Here at the bottom, it says used 4 times. How many questions you can make left? 4 times, 4. Renew on March 13. So what I believe is in the free version, you can read 5 papers, ask for the summary for 5 papers. Maybe you can buy for more papers or something like that. But this is an example of using AI. Even in your reference manager, you can take the paper, summarize, it will summarize for you, and you have 5 every month with Mendeley. Okay, now we will discuss about the efficient article scanning. What is this idea? So you are in the stage where you collected all the PDFs using the 3 different strategies I suggested to you. So you probably have on the order of 100 to 1,000 PDFs. How you will separate the wheat from the chaff. So this is what we are discussing now. Efficiently article scanning. So why you need efficiently article scanning? The article scanning is this a structured process, so it's a kind of an algorithm to quickly evaluate the paper's relevance and contribution before investing time in full reading. So the scan article is not dynamically reading. I think you know this concept, right? Dynamically reading. What's that? It's a way to efficiently read books. But you read everything. This is not what I'm talking about. What I'm talking about is article scanning, only to separate the article for a full read. So it's just a quick read to separate for a full read. What is the strategy? The 6-step strategy. First, you read the title, then the abstract. These 2 are really the most important ones because they are the ones freely available. right? So when you search in Google Scholar, you have access to these two, no cost. If this two indicates the paper is nice, then you can go for the next steps, which is read the conclusions, introductions, figures, and references. You see, it's totally messed up the organization, right? So the first thing you read in the paper is the conclusions. So that's why it's a strategy for article scanning. It's not for article reading, it's for article scanning. You read the conclusions, introductions, figures, and references. Now, why? I will give you some hints on what you have to search while doing this article scanning and to separate the good papers from the bad papers. So in the title, what you should identify: the main variables or systems that were studied, the method or the approach used, and ask the question, is this directly relevant to my problem? So and sometimes you don't even go to the abstract, right? You just go in Google, put your keywords, boom, it comes 700 papers, you go keep reading the title. With the title, you should have already a good answer if this is relevant or not to your research. Look for keywords aligned with your research. So the title and your keywords, as we mentioned in the last class, they should be very well correlated. If you have a keyword that's not in the title, maybe the title is missing. If you have words in the title that are not keywords, maybe there's too many words in your title. So these two, they have to be very correlated. Now you go in the abstract. The abstract, you already have more. Remember, what is the abstract? Mini version of your paper. So in principle, if the authors did a good job, you should have right there enough information to decide if the paper is valid to read or not. Of course, there are always exceptions. One of them, for example, as I mentioned, the communication papers. The abstract is just one paragraph. So it's difficult to take much information from one paragraph. Sometimes you need to read more. But in principle, a regular abstract, you have to identify what is the context of the paper, what is the gap that is trying to cover, bridge the gap, the methods used, the main contribution, and the impact. So you should already have a good idea of that. Now, if any of these points are unclear, the paper may lack clarity. So this is a very good information for you when you are writing your abstract. Your abstract is the most important piece of information of your paper. So it has to be polished at maximum, right? Because people will decide, most of them, if they will read or not your paper by the abstract. The abstract is really important. Conclusions. So once you read the abstract and your title, which is free, zero energy, then if you decide, well, I have to read this paper, then you go to the next level. This next level is to grab the PDF. Sometimes there is some activation energy because you have to enter your CYU, login, etc. Sometimes you do not have the paper in the CYU. You have to ask someone for the paper, so you have to put energy. Now, when you have the paper, then my suggestion is go to the conclusions. Why? Because it's in the conclusions that the author should have summarized the main findings of the paper, right? Remember, you start the conclusions listing what are the main findings. Also, the limitations. There are some future directions in the sense that we did this, but others could keep going, doing that, and etc. So it's important for you to know that. And it's an important step to match if the conclusions match the abstract claims. So in the abstract, you should have presented, the author should have presented what they are going to do, right? In this paper, we present, etc., etc. In the conclusions, right in the first paragraph, you should be summarized what was done. You match these two. They give a match? Yes, okay. So paper sounds to be reasonable. Now you go to the introduction. In the introduction, it's important to read that because you can identify what is the research gap, the proposition of the work. It's important that you observe the citation patterns so that those papers that are cited quite often in the field. And also you can learn how the problem was framed. Remember, in the introduction, we should frame our problem. We should tell what is the problem, what methods we are using to solve it. So we should give the framework of the paper. So even if we are in the stage of selecting the wheat from the chaff, I'm proposing you to read the introduction, yes. But you will read it again in more detail, right, when you read the full paper. But it's interesting to get used to this, to read introductions more than once. Figures and tables. Figures and tables, they tell a lot about the paper. Why? Remember, figures and tables, they have to be a story by themselves. So in principle, you should not need to write a text or many paragraphs of a figure. It should tell the story by itself, by the figure and the caption. So you could check, understand the trends before reading, magnitude of the effects. So sometimes we are looking for example, in this research I'm doing with Tantuan, we are looking for Stokes shift, which is the shift between the absorption and the emission. So if I look at a spectra in a figure, I should be able to immediately detect that, the magnitude of this effect. Another point that's important that we mentioned, error bars and statistic robustness. So is the author presenting just one point or is showing an error bar? Is treating correctly the data? So it's also important to show. And at this point, remember, you have read the conclusions and you can ask this question. Do the data support the conclusions? Do you agree that what the guy concludes is in agreement with the figures that are shown? So this presents consistency of the paper. Is the paper consistent? Yes or no? References. Now, go to the reference. The references can tell you a lot about the paper, right? And one of the points that you should check is, for example, identify the highly cited foundation works. So remember, everything starts with 3 or 5 highly cited papers. Those are the foundation works of your field. Does this paper cite this work? It's a good one. Did the guy do a very nice reference search as you are planning to do? You can detect in the references of the papers you read recurring authors. So the authors that always appears in the papers. So maybe if you missed one important author in the first search, you can catch another one by reading the references of the paper. Oh, I missed that guy. This guy has 10 papers cited here. Why? So you can add one more. Always search for recent review articles. So there are some review articles in the past that they were very few journals, but nowadays there are many journals, many review journals. So when you tell me about what is a journal that you think about when you talk about review article, I tell you right away, chemical reviews. But there are many others, right? So sometimes you can find nice review articles looking in the references. So the idea is always expand your literature map. When to stop reading? Stop reading when paper is off topic, nothing to do with your research. the method is irrelevant to your research. So it's something that you don't have, that methodology is out of reach, so sometimes not important. No contribution beyond known work. So sometimes you catch a paper that's old and others have done way more advanced things. So, and of course, poor clarity. When the paper is difficult to read and it's complicated, maybe you should just take another one. Now, just to finish up right in time, we go to the last topic, which is intelligent search strategies. They are very simple strategies, but they are very powerful in the search of this immense number of papers, right? And I have used these strategies in many situations. The last situation I used in Brazil, we have a document portal, so it's in the web. So all the documents, official documents of the university, they go through this system of information. And I am now in the process of asking for my last promotion, and I need documents that are in the search platform. And then I was just searching for my name, and I was getting thousands and thousands and thousands of documents and reading through all of them. It was just a nightmare. Then I said, no, I believe this thing has some kind of advanced search. When I found that advanced search, it changed from water to wine. Because I could just target exactly what I want. The number of documents reduced infinitely, and I could check all of them. So what is intelligent search strategy? So the idea is to systematically reduce the information overload, maximizing the relevance, quality, and novelty of the searches that you retrieve. So for example, something very simple like that you can use in Google Scholar, which are these keywords there. So when you put in quotes something, then it will search for that exactly. So it has to have this keyword there. Then you can use these words and or to limit the search. And then there are many others, you can search for others, no? It's not only that. You can also add file type, for example, file type, semicolon PDF, and cite, semicolon edu, or, because one is the contrary of the other, right? Here you find web pages, here you find articles. So one suggestion, for example, is here. I did this search. Exciton dissociation, quotes, and C60, quotes, and pentacene. So when I do that, I will only get papers which talks about exciton dissociation in C60 and pentacene. So all these three keywords, they have to be on the paper. So you reduce dramatically the amount of papers. If, for example, you want to get rid of websites, you don't want HTML pages. As I mentioned, Google Scholar has everything, right? HTML, papers, theses, and etc. Then you can come here and just add this one, file type 2 points PDF. So it will only list PDFs. Oh, but if you list PDFs, then you use theses. You can get also theses and citation. That's more than that. So you can also try to find other to exclude. So when you want to do a focused research, the third one, the second one, use these keywords. And most of the websites like Web of Science, Google Scholar, all of them, they have these keywords like and or that you can add to reduce the search. One point that's important in citation intelligence. For example, in the Google Scholar, when you do a search, when you click the article, you have this kind of information here. Number one, number of citations. Number two, who cited it, which is the forward, right? Citation. And is it cited in reviews? So when you take all the citations, you can see reviews there that cited this guy. So this is citation intelligence. You are learning more about the paper, not for the content, but for the community, right? Word of caution. High citation doesn't mean high quality. But low citation in an old paper is a warning sign, right? So if you have a paper that's 5, 10 years and it has 5, 6 citations, maybe this is not so important. But maybe it was just not found. Reviews versus original papers. So reviews are very useful to enter quickly in the field. They basically did part of your work, which was review all the massive amount of papers there. So in that 3 to 5 highly cited paper, I tell you, you should have at least one review. Really important. You learn the terminology. Usually those are big papers, 30, 40, 50 pages. So you quickly learn the terminology. You identify key authors, because usually they cite a lot of people. Whereas in original papers, then they go deep into each method, each material. So you identify weaknesses of the field. You can find help to build your argument for your paper. So most likely you will have many original papers versus few reviews, but make sure you have at least 1 or 2 reviews in your citations. AI, the use of AI. So AI-assisted search, always with caution. What kind of caution? AI is very good to summarize, to suggest related works, and to clarify terminology. This is really nice, right? Sometimes you have a terminology there, you don't know what is that, then you can go AI. What is absorption spectrum STM? Okay. Suggested related works with caution, right? Check the reference, open the paper, always use your intelligence. AI cannot replace critical reading, guarantee correctness, and replace database search. So this one guarantee correctness. All of us already have touched this field, right? To write ChatGPT and ChatGPT is wrong. So you're wrong. Oh, I'm sorry. Also, right? So don't fall into that. AI may accelerate, but it does not validate. Validation is on you. You should validate the paper. Common literature mistakes, just to wrap up, listing papers chronologically. So in the introduction, people sometimes try to write the introduction to list the papers chronologically. There's no reason for that, right? Remember, one thing is the exploratory research. The other thing is the explanatory. One, you are just maybe looking chronologically. The other one, you're just telling a nice story. You can change the way you present in time as well. No critical comparison. So your thesis, one time I was in university in a committee that evaluated people theses that were defended abroad in Brazil to validate if they could represent the same diploma in Brazil. And we grabbed a paper, well, a thesis, that had just thousands and thousands of papers. And the author was just right, oh, in this paper he did that, in this paper that guy that said that, and the thesis was over. But what was your work? You just talk about the others. And we rejected that. So you have to have a critical comparison. This guy did that, the result is this, but that guy did other things, the result was different, but you have to work on the reference. Huh? No identified gap, no synthesis, and excessive quotation. So you just cite, and you not discuss. So it's a common mistake. And finally, to wrap up, take-home messages. So effective visual display of information. Keep that word in mind, cognitive load. Reduce cognitive load, especially in presentations and when you have proposals that people have not much time to devote to your material. Bibliography research. Literature review is not just a list of papers, it's a structured map of your field, right? So you have to answer what is known, you have to know what's debated, problems, and this will help you to define your contribution. So you need to know the landscape for your field to position very well what is your contribution. It's relevant, it's really a gap that no one looked at, so you only have these answers if you have your landscape built. The reference management, the idea is to improve accuracy, especially accuracy and efficiency, and poor management will definitely undermine the quality of writing in this scientific reliability. So if you do not have a management of your research, when you write your thesis, when you write your paper, it's just a big mess. Finally, efficient article scanning. Not every paper deserves a full reading. Should keep that in mind. Nowadays, we have so many, you have to separate the wheat from the chaff. And the efficient scanning allows you to evaluate quickly the relevance, novelty, and increase the productivity while preserving the intellectual depth. And finally, the intelligent search strategies. Information is abundant, but relevant knowledge is scarce, right? So the expertise of intelligent searching begins knowing on what to search. So information is abundant, relevant knowledge is scarce. So you have to build intelligence to separate that. Okay, with that, we give the references and finish up. Thank you very much for your attention. If you have questions, I will be glad to.